Lesson 1-5, we're going to add and subtract rational numbers. So these are going to include integers, as we've already learned how to add and subtract, but we're also going to include fractions and decimals that are either terminating or repeating. We're going to use the adding and subtracting integers rules for all rational numbers. So remember these rules. They said that if it's subtracting, that you're going to add the opposite. And then once you have an adding problem, if they're the same signs, you add and keep the sign. If they're different signs, you subtract and take the sign of the number with the greatest absolute value. Example 1, negative 2 3/4 plus 5 1/4. So you might notice that we're adding different signs. So we would think of this as a subtracting problem, and it would be helpful, since this is not something you can easily do in your head, to just write this down. And I might put a little step out to the side that says something like think, just so that I know that this isn't the exact same problem, but it's the way that we're approaching the problem. And so I'm going to take the number further from 0, which is 5 1/4, and I'm going to subtract the smaller number, the number that really is technically closer to 0, 2 3/4. And we have the same denominators, so that's helpful. I do need to borrow on this 5 1/4. I'm going to borrow 1 from the 5 to make it 4. And I'm going to add 1 to 1/4 to make it 5/4. So I've got 4 5/4 minus 2 3/4. Well, that would be 2 2/4, and we can reduce 2/4 to 1/2, so we get 2 1/2. And we're almost finished, but I do need to go back and check my sign. So I'm going to just go ahead and note that here just for me to think about it. I had a negative plus a positive. And which number has the greatest absolute value, as in it's further from 0 on a number line? Well, that would be 5 1/4. It was positive, so my answer will be positive, and it's positive 2 1/2. Example 2, negative 0.49 plus 1 1/2. This problem is different because we're adding two numbers that are represented in different ways. One is written as a decimal, the other is written as a fraction. So anytime that is the case, you're going to need to change to both fractions or both terminating decimals. Now, we don't do this with repeating decimals because we don't quite have the background to add and subtract with repeating decimals. So if they turn out that way, they'll need to convert to both fractions. So I noticed that 1 1/2 is a fraction that I can change to a decimal. So I'll start there. I have negative 0.49, and I'm going to add 1 1/2. You may recognize this as being 1.5. If you forget how to do this, just a reminder, I could go over here to the side and I could think of 1/2 and change it to a decimal. All I have to do is divide 2 into 1. 2 won't go into 1, so I place a decimal and place a 0 behind the decimal. 2 will go into 10 5 times. 5 times 2 is 10. And I have no remainder, so I'm finished. So 1/2 is the same thing as 0.5. So 1 1/2 is 1.5. So now I notice that I'm adding a negative 0.49 to a positive 1.5. So I'm adding with different signs. So I'm going to go ahead and use some scratch work here and think about this. If I'm adding different signs, then I'm actually going to subtract. So I have 0.49 and 1.5. So I'm just going to subtract 1.5 minus 0.49. Maybe easier to write this vertically. So I have 1.5 minus 0.49. And I'll use a 0 placeholder behind 1.5. So we can just line up our decimals and subtract. Have to borrow. And I have 10 minus 9 is 1. 4 minus 4 is 0. And 1 minus 0 is 1. So I've got 1.01. So we subtracted because they were different signs. And now we're going to keep the sign of the number with the greatest absolute value. Well, 1.5 is further from 0 than negative 0.49, so it just stays positive. Example 3, 1/2 minus negative 2/5. Well, I'm going to start with my integer rules, although these are not integers, but we're going to go back and think about subtracting integers. And it says that we're going to add the opposite. The opposite of negative 2/5 is positive 2/5. And so now we have two positive numbers that we're adding. Same signs, add and keep. So we're just going to add. We can't add yet because our denominators are different. So I'm going to think of a denominator that both 2 and 5 will go into. And I know that they'll both go into 10. And so 2 times what is 10? That would be 5. And 1 times 5 is 5. So 1/2 is equivalent to 5/10. 5 times what is 10? Well, 5 times 2 is 10. So 2 times 2 is 4. And 2/5 is equivalent to 4/10. Now that we have the same denominator, 10, we just add our numerators. 5 plus 4 is 9. And 9/10 is simplified. We can't reduce it any further, so we're finished. Now it's your turn to try a problem. Go ahead and try this using your integer rules, which we also use for rational numbers. Notice that you have a decimal and a mixed number, so you'll have to think about whether you want to change them both to fractions or change them both to terminating decimals. And then go ahead and try this problem, pause the video, and then come back and check your answer. Okay, so we are subtracting, so we'll go to our rule that says that we're going to add the opposite. So we have negative 7.2 plus negative 3 4/5 is the opposite of positive 3 4/5. We'll also notice that we have a decimal plus a mixed number, so we need to either put them both into a fraction form or put them both into a decimal form. So I might go to the side and see if I can write 3 4/5 as a decimal, because it's easiest to add and subtract decimals. So 3 4/5, I know that's going to be 3 point something. So to say 4 divided by 5, I can use long division. 5 won't go into 4, but it will go into 40 8 times. 8 times 5 is 40, and we've got a remainder of 0. So this is 3.8. So that's helpful. So I'm going to rewrite 3 4/5 as 3.8. So I have negative 7.2 plus 3.8. I'm adding different signs, so I'm going to actually subtract. So I'm going to go to the side and think about that. I'm going to subtract and start with the number with the greater absolute value. 7.2 and subtract 3.8. It's easier to do this vertically. 7.2 minus 3.8. Need to borrow from the 7 to get 6 and 12. And so 12 minus 8 is 4. And then our whole numbers, 6 minus 3 is 3. So we get 3.4. And I could go ahead and write that down over here. But remember, I've got to consider the sign. The number with the greater absolute value was negative 7.2. So I need a negative answer. So I've got to put a negative in front of 3.4 to get negative 3.4.